Okay, so today we will start relative motion in two dimension. Okay, this is the last topic of this chapter, relative motion in 2D. After doing this topic, then vectors I will start, because vector formulas are important to do that, but not much detail, because vector is a topic in maths. In maths you will be studying separately. Okay, so what is relative motion in two dimension means, suppose this is a object A and this is a object B. Okay, and let us say previously in one dimension, if you remember, when we have studied that both the particles are moving in the same line. Okay, you can mute your okay. So both the particles are moving in the same line means that was one dimension motion, but in two dimension they can move in any direction. Okay, so let us say that this is going to move in some direction with a velocity va as vector, and this can move in any direction, like this direction, let us say vb vector. Okay, these are vectors now, and let us say that the distance between them is some distance will be there. Okay, so what is motion, relative motion with respect to one? Suppose if I study motion of B relative to A, I want to study motion of B relative to A. Relative to A means what? Relative to A means observer will be at A. Now observer will be at A, right? So what does that mean? Observer will be at A. What does that mean? An observer will be, the person A itself is the observer. Okay, so he will not see himself moving. He will not see himself moving. He will see everything else moving, right? He will not see himself moving. That means what? He will start giving negative velocity to others. First of all, he has to stop himself because he is moving. So to stop himself, he will give his own negative to himself. Okay. So what he will do is, first you understand, this is a very important thing. To stop himself, what he will do? He will add a negative velocity minus Va to himself, because plus Va minus Va will become 0, correct? Plus Va minus Va will become 0. So not only to himself, to everyone. So he will give this minus Va to this also. Minus Va vector he will give to B also. Okay. Now what will happen? Now if you see this observer, he is not going to move. Okay, this point A is going to be at rest. Why? Because this plus Va minus Va becomes 0, and he will be seeing this point B moving. Which direction he will see point B moving? Because you need to add the resultant of these two vector. This is minus Va vector and this is Vb vector. So you should know some idea about addition of vector. I'll briefly write the formula for that. Suppose this is A vector and this is B vector. Okay, and they are making angle theta. So according to parallelogram law, you know that, right? Parallelogram law says that the resultant will be this vector R vector. The resultant magnitude is given as root under a square plus b square plus 2ab cos theta. Everything is inside the root. You know this formula, resultant. Okay, so resultant is nothing but the diagonal, and resultant makes some angle alpha with the first vector, beta with the second vector. So this tan alpha is given as b sin theta by a plus b cos theta, and tan beta is given as a sin theta by b plus a cos theta. So this much we should know right now. Okay, we should know right now this much. If you have to add two vectors, how to calculate the resultant. So two vectors are making angle theta between them. The resultant will go making an angle alpha and angle beta with each of the vectors. And the magnitude of resultant is given by this formula. Tan alpha tan beta is given by this formula. And note that this is called parallelogram law. Parallelogram means it is the diagonal of the parallelogram. The resultant vector is the diagonal of the parallelogram. Okay, parallelogram law. Okay, right. Clear. So now the same thing you apply here. You apply the same thing here. This vector here, this is like a vector. Okay, and this is another vector here. Two vectors you are adding. So parallelogram you make parallelogram. Parallelogram will be going here, right? Somewhere here it will go. Correct. So what is this? This is the resultant of VB and minus VA. VB and minus VA. This is called VB with respect to A. It is the resultant of VB and minus VA. You are adding VB vector and minus VA vector, which you can say as VB minus VA also. Okay. So VB with respect to A, right? VB with respect to A is nothing but VB vector minus VA vector. And this direction will go in some direction, right? VBA. VBA. So now this person is just going to study and he will see that V is going with this velocity. That's all. That's all. Clear? Are you clear about this? This is what is motion of B relative to A. Similarly, what is motion of A relative to B? Let us see that. What is motion of A relative to B? So A was going like this, right? And vector, and B was going somewhere here. Okay. So now you have to study A with respect to B means observer is the B. B is the observer now. Okay. B is the observer. So what this observer will see, he will not see himself moving. So what he will do? He will add the negative of B to himself first. Negative of B he is adding himself, so that he will become at rest. And not only he will add negative to himself, he will add his negative to everything else. He will add his negative to this also, minus V. Okay. So now what will happen here? This distance is of course D, some distance is there. So he will not see B moving. B will not be moving according to this observer. Okay. This B is going to be at rest. Okay. And when he is going to see A, what he will see A? What he will see A? So now he will see resultant of this. Now make resultant of this parallelogram you make. This is the resultant of this. This is resultant of this. And what is this resultant? This is VA vector plus minus VB vector, plus minus VB vector. This vector itself, VA vector plus of minus VB factor, is called VA vector minus VB vector, and this is called VA with respect to V. This is called VAB. So it is going in some this direction. Okay, this is VA with respect to V. So now this observer will only see the body A moving in this direction. That's all. Right, he will not see any other thing. He will see that A is moving in that direction. That's all. Okay, this is what is relative motion of A with respect to B or B with respect to A. Okay, clear. Hmm. Hmm. What you're saying, this he is becoming at rest. Okay. Hmm. Yes, that's what he has added minus VB to that. So there is a huh. We have added, no, you did not see. See, when observer was here in the A, he has added, no, this, can you see here? This is minus VA added to B. That is what it is. So observer, he, wherever the observer will sit, he will add that negative to everything else. Okay. Observer was at A, so he has added minus VA in everything else. So when he added minus VA to himself, he become rest, and when he added minus VA to B, so this will become VB minus VA, that is VB relative to A. Similarly, here when this observer is at where this case, when observer is B, he is added minus VB in VA. So VA minus VB, that is what is VAB. Clear? That is what it is. Are you understanding this? Okay. Now we will go to example. First we have to understand with example calculations we can do. This vector formula which I have given, that you have to apply. Okay. Let us take example. Then there are some classic example. Classic example is man umbrella problem, river boat problem. Two problems are there. Okay. Let us say this is A and this is B. Okay. Uh, this is the line joining between them. Let us say that this is 10 kilometers. Okay, 10 kilometers. And A is going this direction. Let us say, no, maybe let us take a good question like this. Let us say that these 2 points are there. This is going like this way, and this is going like this way. This direction, and of course, this direction is 90 degree. This is A and this is B. Okay, first question. So A is going with this speed in this direction. Let us say uh, 10 meter per second. Okay, and this is also going with 10 meter per second. And the distance between A and B is, let us say, 100 meter. Okay, so now this is a very good question, very good question. You have to understand that. So A and B are lying, for example, in the road. If you see horizontal plane, A is towards the north and B is towards the south. Okay, A is in the north, B is towards the south, and the distance between them is 100 meters. Okay, and A is going in this direction and B is going in that direction. Okay, that means their velocities are perpendicular 90 degree. Now the question is find the time when the distance between them is the smallest, and also find that smallest distance. Okay, so note that B is going in this direction straight line, A is going in this direction straight line. When will be their distance become minimum? That is the question. How will you solve? You have to apply relative. Okay, Suppose these are two cars. Let us say there are two cars. Okay, one is going on a two roads are there. These two roads are like the junction. Okay, junction will be there. So there are two roads. One road is like this way, straight road. Okay, like this. Another road is like this way. Okay, so this is the junction here. Okay, so A is going like this and B is going. After some time, what happen? This person A will come here. Let us say A will come here after some time. B may come here after some time. Then their distance will be like this. Distance means distance between them. Okay, distance between them will be like this. After some time, A will come here, B will come here. Distance will be like this. Distance will keep on changing between them. Correct? So initially distance is this, then these distances will be changing like this. Now think what to do. So let us study relative motion now. Let us study, because when you take relative motion, one will become stop, one will stop. Okay, let us study relative motion. Which one should we choose observer? Tell me. Should I take observer A or B? B is observer. Okay. So we will make B rest. Okay. So B is the observer now. B is now at rest. B is now at rest. This is B. Okay. And where is A? Initially A is just here now. A is here on. So what is the velocity of A? This direction. Velocity of A, this direction is 10 meter per second. Velocity of B is upward, right? So he has to add negative of that. Negative means what? Downward. This is minus of VB. Note that. This is minus of VB, but magnitude is same, right? 10 meter per second. 10 meter per second. I am writing this magnitude, okay? Minus, it is minus of VB, but 10 meter per second. Now tell me, these two are 90-degree, right? Tell me what is the resultant of these two. Tell me quickly resultant of these two. This vector 10, this vector also 10. Draw the parallelogram and show me which will be resultant. Parallelogram you don't know. Draw. This is resultant. Tell me how much this length will be. Diagonal how much? Hmm? This I am using this rate. This is minus VB, which is 10 meter per second. Correct. 10 root 2. So 10 root 2 meter per second, that is the relative velocity. This is the relative velocity of A with respect to B. Okay. But its direction is this way. Note its direction. Direction will be this direction. This is the direction of this. Okay. So B will see that A is moving in this line. B will see A is moving in this line. Okay. Now tell me, what is the shortest distance? So shortest distance means you need to drop a perpendicular, right? Perpendicular. This is the shortest distance. Let us say that this is x. This is x is the shortest distance. Shortest distance. We need to calculate x. Okay. So tell me, how do we calculate x? How will you calculate x? Hmm. that you have already used now. This tan root 2 you calculated by doing triangle or parallelogram law, that same thing, root under tan square plus tan square. That's how you got tan root 2. That's what you have done. This is what is tan root 2 is A with respect to B. This is VA minus VB. But it is a vector subtraction or vector addition. Okay, vector. This is vector addition. Na? This tan are in this direction 90 degree. You have added that. But what I am asking is, what is this x? This distance x is how much? How will you calculate this distance? Hmm? Okay, now tell me, can I take a triangle? Ah, yes, this angle will be 45 degree, right? This angle will be 45 degree. And tell me, do you know this distance? This distance was how much? In the question it was given 100 meter. Yes. So this is 100 meter and this is 45 degree. How much will be x? Use trigonometry now. Trigonometry you use. This is opposite of 45. This is hypotenuse. So you know this the hypotenuse. This is 45 and this. Which trigonometry ratio you can use? Sine, cos. Which can we use? Use trigonometry. Opposite of 45 degree. Right? Sine theta you use na. Sine 45 degree. Sine 45 is what? Opposite by hypotenuse. So x by 100. This is 1 by root 2. You got na x. Huh? 100 by root 2. Or this is 50 root 2. Right? So you got this. Okay. The shortest, the smallest distance you calculated. This smallest distance is 100 by root 2 or 50 root 2. Okay. Now they are also asking the time. How much time it will take? How much time it will take? So if B seeing A starts here, then A will be coming here, here. A will be coming. Here it comes. Okay. So A will take some time to come from here to here. How much time A will take? Can you calculate? Time is equal to distance by root. Yes, good. Because this x is, because this is 45 degree, so this is x, this is also x, right? Correct. You're correct. X, because this distance is also x. Now time is equal to distance by speed, so in this direction speed is tan root 2, so x by tan root 2. Correct, right? So that time will be yes, distance by that distance by VAB. So this is 50 root 2 by tan root 2. Then it will become 5 seconds. Yes, correct. Got it? Yes. So this type of questions are there. Hmm? Okay, then you can solve this type of problems. Clear? You can solve this type of problems. You have to make the vectors and you need to look like this and do it like this. Okay, let us go then next. Next, this model question you can solve. Next, we can go. Now we can go this man umbrella problem. Man umbrella problem. Man umbrella problem. So what is the man umbrella problem is that or rain man problem. Sometimes it is a rain man problem. Rain man problem. Okay, so what happened is that there is a man, let us say, this is a man, and this man is standing right now, it is rest, okay, rest. And he is seeing that rain is falling like this downward. Okay, this is the velocity of rain. VR means rain velocity, rain velocity. So he is seeing that rain is falling downward. Okay, and he is holding umbrella. Okay, he is holding umbrella because he will otherwise get wet. So he is keeping umbrella like this and he is holding it. Hmm? Rain is coming like this. So with his hand, he might be holding it. Okay, let us say he is holding it. Of course, there will be uh, this handle of the umbrella will be there. Okay, so suppose that this is the handle of the umbrella handle, and this man will be holding this umbrella. Okay, man is holding. Man is right now rest. Man is rest, and he's seeing rain is coming directly downward. Now what happened? Man started running with the umbrella. Man started running. Okay, so now man is also going to move. Man is going to move with some velocity Vm. Vm is man's velocity. Man's velocity. Now the question is that he cannot keep the umbrella same way. He has to tilt the umbrella in some direction so that he can protect himself. Okay. So now which question is which direction he should keep the umbrella? He should tilt the umbrella somewhere like this. Okay. Which direction he should tilt the umbrella? Okay. So he cannot keep the umbrella same direction. So this umbrella has to be tilted up. Why he has to do it like this? Because now the relative velocity of the rain is different. Previously man was not moving, so he was seeing rain coming down. Now he is running, so he will see rain coming in different direction. Okay, he will see the rain coming in different direction. That means you have to find out velocity of rain with respect to man. That is what you need to do. Now first we will draw this diagram afterward. First find out velocity of rain with respect to man. So man is going this way, this is the man, right? So let us man be at rest. Let's man be at rest. Relative to man, you are seeing which direction rain is going. Rain was going this way. This is velocity of rain. Okay, man is going forward, so he have to give a negative velocity, right? This is the minus velocity of man. Okay, note that this is man is seeing, right? So man has to give his, man is the observer, so man has to give negative. Okay, these are factors. Note that these are factors. Now resultant of these two factor will be what? Let us add these two factors. So when you add these two factors, resultant might come in this direction. Okay, resultant may come in this direction. This I will first remove that. Okay, resultant will come this resultant is the velocity of rain with respect to man. Velocity of rain comma man. Okay, this is the velocity of rain with respect. So this person has to keep the umbrella in that direction. Okay, because he is seeing the rain is coming in this direction. In this direction he is seeing. Okay, in this direction he is seeing now. So he has to keep his umbrella. He need to hold the umbrella in that direction only. He need to hold the umbrella in this direction. Okay, this direction. So which direction means how much angle it will make with the vertical. How much angle it is making with the vertical. How much angle this is making with the vertical. This angle. So tell me how to calculate this angle. How do I calculate this angle? Angle with the vertical, note that angle with the vertical, this is the angle with the vertical. How do you calculate this angle? This triangle you can clearly see, right? In this is anyway 90 degree, let us say this triangle. So this is the velocity of the man and this is the velocity of the rain. So tan theta you calculate, tan theta. Tan theta from this is velocity of man by velocity of rain. That is the answer. So theta can be calculated from here, tan inverse velocity of man by velocity of rain. Clear? So he need to hold his umbrella, handle of the umbrella, he has to make theta angle with the vertical. This is the angle theta. Clear? Are you clear about this? Hmm. Okay, this question was very easy. Why? Because previously the man was not running. Man was stationary. But suppose initially itself man was running, and initially he is saying that rain he is seeing at some angle theta 1. Then he starts changing his speed and he sees the angle changes theta 2. Then how do we calculate that? Very, very important thing. Okay. Now let's understand this very important, for I am going to make a formula for this, and if you remember you can use it. Okay. Let us see that. Suppose this is the man. Okay. This man was already running with a speed v of man 1. I am writing v of man 1. Okay. And he was originally seeing the rain. According to him, he was seeing the rain in some direction with the vertical. So he was seeing this rain, velocity of rain first time. It was making some angle theta 1 with the vertical. Remember, this is not the velocity of rain because now he is moving. So what he is seeing is relative velocity. So this speed is nothing but velocity of rain with respect to man in the first case. Okay, this is velocity of rain with respect to man in the first case. Okay, next time when he had changed its velocity, now next time he has changed its velocity. So his velocity has now become v man 2. Now this time he is seeing the velocity of rain with respect to man, second time it is. This is making some angle theta 2, theta 2. Okay, this condition is given in the question. In the question they are saying that they will give you values. Okay, they will say that the man is running with, let us say, 10 meter per second, and he is seeing this rain is hitting at an angle of 30 degree with the vertical. Then he increases his speed to 20 meter per second. Now the rain is hitting at an angle of 60 degree to the vertical. What is the velocity of rain? That is the question. Okay, so from this information you have to find the velocity of rain. Find the velocity of rain. This is the question. This is a very difficult and complicated question. Okay, but if you derive the formula for this, then you can just use that formula in your NEET. Okay, how do you do that? So first we need to write one important formula. Tell me what is velocity of rain with respect to man. Vector I am writing. Okay, vector. Velocity of rain with respect to man is velocity of rain minus velocity of man. Okay, velocity of rain minus velocity of man. So velocity of rain will be what? Velocity of rain will be velocity of rain with respect to man plus velocity of man. That means this you have to add. So when you add these two, then you will be getting this. Okay, so basically idea is this only, rain velocity will be calculated by this. So first time you have to add these two, second time you have to add these two, right? And the addition of these two will give the same vector because velocity of rain is a fixed vector that cannot change. What is changing? Man is changing his velocity, so relative velocity is also changing. What is not changing is the rain velocity, and that is what they are asking in the question. Clear? You have to understand what is changing and what is not changing. Rain velocity is not changing. It is relative velocity of rain which is changing. Why? Because man is changing his velocity. So one time he has to put umbrella like this, next time he has to change the angle of the umbrella. Okay, so how to solve this type of problem? Hmm? Okay, how will you solve this type of question? So to solve this type of question means you need to do it like this. This relative velocity is there, na? This relative velocity break into two components. So you know how to break components. This VRM1 cos theta 1 and this is VR VRM1 sin theta 1. Okay, I have broken into components and I think you should know about x component. Horizontal, horizontal is C, horizontal is this one. This is x axis, this is y axis. Okay, whichever direction it, there is nothing like x axis, y axis. See, I think you may be confused about which side I should write cos theta and which side I do sin theta, right? See, this confusion you have to first clear this, okay? This confusion you have to clear. This is called resolution of vectors, okay? Resolution of vector. Resolution of vector. Suppose this is a vector, okay? Let us say it's a velocity vector. And this velocity vector makes angle, let us say theta with this direction, okay? This is some direction it is not x axis and y axis. It is some direction. With this direction it is making angle theta. Okay, now how to resolve this? So to resolve this you have to break perpendicular. One perpendicular is like this, another perpendicular is like this. Okay, this is called resolution into perpendicular components. This direction need not be x axis y axis, okay, but these two direction has to be perpendicular. This is what you have to understand. Okay, so this direction which is making theta, that is v cos theta and other one is v sin theta. First you need to understand this. Clear? Clear or not? Clear. Okay, so once you understood this, now coming to this one, how did we resolve this? So know that this angle theta is with this direction, so this is cos theta component, this is sin theta component. That's what we have done. Similarly, now here you tell me how to do that. Same manner you do it here also. So this side is theta 2, right? So this will be vrm2. Again, that direction is theta, na? Whichever direction is theta, that is cos. This direction is theta, na? This is cos. Other direction is sine. Okay. Other direction is sine. So we want to sine theta 2. Okay. Okay. We have done this. Okay. After that, what you need to do is you have to write this resultant vector. Okay. Using this, let us write the first case. So in this first case, when you are writing this VR vector, first case I am writing VR vector. Okay. So horizontal component is this side and vertical component of this side, and this is, so first of all let us write a horizontal component. First you should know that in this direction, if I choose this as x axis, a unit vector along x axis is I cap and a unit vector along y axis is j cap. You know this? Yes or no? I cap, J cap, you know. Okay. So now you tell me what is VR vector? VR vector is VRM vector plus VM vector. This is what it is. Okay. Now VRM vector has two components. One is negative x-axis and one is negative y-axis. So let us write them as minus VRM1 sine theta 1 I cap minus VRM1 cos theta 1 j cap. Okay. minus I cap minus j cap means they are negative x axis, negative y axis, and Vm is going in positive direction. So plus Vm1 I cap. Okay. So this is what we are getting first time when we are writing. Now let us club the I cap together. Okay. Let us write I cap together and j cap together. J cap together. So what are the I cap? I cap, where is this? Here is I cap, here is I cap. Okay. So let us write this is V1, this is plus and this is minus. VRM1 sine theta 1. Ah, minus VRM1 sine theta 1 I cap minus VRM1 cos theta 1 J cap. See, here you see now this direction. This direction, this direction you see. This direction is tell me positive x axis or negative x axis. This direction. That's why na minus I cap. So minus of this I cap. Understood? And this direction is which direction? Positive y axis or negative y axis? And that's why minus j cap. Okay. So that's why this minus I cap you can see here. This minus I cap is coming because of this is in this direction negative. Similarly here minus j cap is coming because of negative z direct negative y axis. Okay. And why this is coming positive? Because man is going in positive x axis. So Vm1 is you can see it is coming positive I cap. Correct. Now we are bringing it together. Okay, now we are bringing x I cap and j cap together. So I cap I have taken common. So here I am writing plus Vm1 minus Vrm1 sin theta. Similarly j cap I have taken common. J cap I have taken common. So if I have taken common, so I will write this minus Vrm1 cos theta 1. Okay. So I component is this, j component is this. Clear? We got this. Now same thing you repeat for the second case also. Same thing we have to repeat the second case. Okay. So we have got this. First you highlight this. This is the x component and this is the y component. Okay. Now this is not going to change because this is velocity of rain. Similarly, we will calculate velocity of rain from the second figure. Okay. Let us do that again in this case. This is the second figure. Okay. So let us do this calculation here. Velocity of rain is equal to velocity of rain with respect to man plus velocity of man. Okay, now write. Here this component is again negative, this is also negative, both are again same way negative. So I will write Vrm2 sine theta 2 I cap. Similarly minus Vrm2 cos theta 2 j cap. Again man is positive direction, so plus Vm2 I cap. Same way, let us do this. Again bring them I together. So here again this minus I cap is there, right, and minus j cap is there, and this is plus I cap is there. Okay, so let us bring them together. So again I cap I will bring together, again j cap I will bring. So I cap Vm2 minus Vrm2 sine theta 2, and this is minus Vrm2 cos theta 2. Correct. So here also we have got this I component and this j component. Clear? Here also we got it. Now after that what we need to do, because this vector has to be same vector, so we have to equate the I component and we have to equate jj component. Let us equate that. Okay, equate the component. So equating the components, equating the components you equate. Here was Vm1 minus Vrm1 sine theta 1, that will be equal to Vm2 minus Vrm2 sine theta 2. Similarly, this component which is minus Vrm1 cos theta 1, that side minus Vrm2 cos theta 2. So we have got these two equations. Yes, we have got two equations. This is first equation and this is second equation. Two equation we got. Now how to solve these two equation? How do we, what do we know? We know theta 1, theta 2. We know theta 1, theta 2. We know V1, Vm1, Vm2. Right? We know Vm1, Vm2. Two things we know. What else? We know. Because man was going with this speed and rain was coming this angle. Man had changed his speed. Now rain is coming at this angle. We need to calculate. Um, we need to calculate rain, right? How do you calculate from these two equations? Think about it. Can we VRM1 can we write in terms of VRM2 and substitute and solve? That's all. That's all you have to do. So from this equation, cancel minus minus and let us take VRM1 as VRM2 into cos theta 2 by cos theta 1 and substitute back in the first equation. Substitute it. What do you get now? You got Vm1 minus this you substitute. So Vrm2 cos theta 2 by cos theta 1 into sin theta 1 is equal to Vm2 minus Vrm2 sin theta 2. Now Vrm2 you bring one side, bring Vrm2 one side. Bring this. Which side will bring? Any one side you bring. That side is also there. This side, let us bring this side, okay, and this Vm1 take that side. So Vm2 minus Vm1 is equal to this you bring that side. So Vrm2 sin theta 2 minus Vrm2 uh, cos theta 2 cos theta 1 sin theta 1. Okay, now we will take Vrm2 common. Let us take Vrm2 common. So Vm2 minus Vm1, Vrm2 I have taken common. Then it will become sin theta 2 minus cos theta 2 sin theta 1 by cos theta 1. Now I think some trigonometry simplification will come. Let's do that. So take Vrm2 and here take LCM. LCM you take. So sin theta 2 cos theta 1 minus cos theta 2 sin theta 1. Tell me, is there any formula? Sin A cos B minus cos A sin B. Correct? Sin A cos B minus cos A sin B. What formula it is? Tell me, what is the formula? Trigonometry. Sin A cos B minus cos A sin B. Sin A minus B. So sin theta 2 minus theta 1. Good. This is coming a formula. Yes. So from here we got, what do you got? We got Vrm2. We got Vrm2. Vrm2 is what now? Vrm2 is Vm2 minus Vm1 multiplied with cos theta 1 divided by sin theta 2 minus theta 1. Good. We got this formula. Vrm2. Still we have not got Vm. Sorry, Vrain. We wanted to calculate Vrain, right? Vrain we wanted to calculate. So Vrain, how do we calculate Vrain? Vrm2 we have calculated. Vrain, how do we calculate? Vrm2 we have calculated, no? Here we can substitute. Here we can substitute and we can calculate now, because this is the velocity of rain. Correct? Yes, did you get? Because now we calculated VRM2. Correct? VRM2 we have calculated. We will substitute here and we'll calculate velocity of rain. Clear? So now I will summarize that. This, remember this, Vm2 minus Vrm2 sin theta 2 plus minus Vrm2, that. Okay, right. So you need to calculate this. Once you calculate this, you go to the second diagram. In second diagram, if you remember, this was the velocity of the man. This was velocity of man, right? And the rain velocity, relative velocity Vrm2 was this. Correct? I will draw it here. That will be better. I will draw this here. Vrm2. Vrm2, Vrm2 was here, and this was making angle how much? It was making angle theta 2 with the vertical. So tell me, this angle is 90 degree, correct? So what is the angle, total angle between them? What is total angle between them? Yes, yes. And the resultant of these two, that is the velocity of rain. So velocity of rain you will calculate as root under Vm2 square plus Vrm2 square, a square b square, plus 2ab Vm2 into Vrm2 into cos of total angle, cos of 90 plus theta 2. This is how you will calculate. And what is Vrm2? This is what Vrm2. You have calculated this Vrm2, and you already know Vm2. You know theta 2. So you need to substitute this here in this equation and solve. You will get the velocity of rain. Understood? This theta 2 they will give in the question now. Theta 2 they will give. Theta change from 30 to 60. So final angle is 60 degree. They will give that question. Got it? Very, very important. Now see, I will show you the power of this formula. Otherwise it's very difficult, no, deriving this whole lengthy derivation, very lengthy. But if you use this formula, one question you see how to use this formula. So suppose, and you should note that if you increase your speed, okay, that this angle may change, right? Suppose if it is going downward, and if you increase your speed, then this angle may increase. Okay, let's take example. So initially the man was going, let's take just a rough calculation, full calculation may not be done. It is going with 5 meters per second. Okay, and he saw that the rain was coming at an angle of 30 degree. He saw that it was coming 30. Now the man has changed his speed to 10 meter per second. Okay, and he saw now the rain is coming at an angle of 60 degree. This information is only given. Okay, and they will ask, tell me the velocity of rain. Tell me the velocity of rain. When he was going with 5 meter per second, he saw rain coming 30 degree. When he was going with 10 meter per second, he saw rain coming 60 degree. What is velocity of rain? First thing you do this one. First thing you do this. First you calculate this formula which I have derived here. Tell me what is Vrm2. Calculate. So Vm2 minus, so velocity of man, subtract 10 minus 5. 10 minus 5 you do. And this is cos theta 1. Cos theta 1 means this, cos 30 degree. This is cos 30 degree divided by sine 60 minus 30, sine 60 minus 30. So tell me, this is quite easy to calculate. 10 minus 5 is 5, cos 30, and this is sine. This means cot 30. Cot 30 means root 3 it will come. Correct? So you got 5 root 3. 5 root 3 you got. Now substitute here and get the answer in one step. Huh? Huh. Take na. So cos 30 by sin 30 is cot 30 na. Cot 30 you substitute na root 3. Hmm. Now you substitute directly this formula. This formula now directly will substitute. So velocity of rain will be root under. Very easy. Do this. Tan square. Tan square plus this square. This square means 5 root 3 square. 5 root 3 square plus 2 into tan into 5 root 3 into cos of, okay, you know what is cos 90 plus theta? What is cos 90 plus theta? Minus sin theta. Okay, so this cos 90 plus theta can be written as minus sin theta. So it will become here minus, I will write. Okay, minus, it will become minus sin theta. So this will become minus sin theta 2. Theta 2 is 60 degree. That is sin 60 degree is root 3 by 2. Okay, now take. So this 2 will get cancelled. So V, then you got the answer. Root under 10 square is 100 plus, do that, 5 root 3, 5, 5, 25, 25 into 3, 75. 75 minus 5 into 10, 50, 50 into 3, 150. So how much it is? 175, 125, 5 meter per second. This is the answer. See, fast calculation. Right. So this question, this much only calculation is needed. This will be given in the question and you will use this formula, 2 steps you will solve. This is the power of this formula. Nowhere in the books it will be given this formula. This formula only can be derived. Okay, clear? Hmm. No, no, even otherwise how will change? If man does not change his speed, why the rain angle will change? Man is changing, then only angle is changing, na? Correct? Okay, right. So here you can write minus sine theta. Okay, this formula you little bit you read this formula. VR will become root under Vm2 is Vm2 square plus Vrm2 square minus 2 Vm2 Vrm2 sine theta 2. Okay, that's all. So you can do that. Read the calculation. Clear? So very important formula you can solve. So this is what is rain man problem. Any type of questions can be solved in this. then is next uh, river boat problem. River boat problem. You have taken your dinner. Dinner. You have finished or not? When you will take? So what to do? Shall we wind up here or continue? Ah, tomorrow will continue. Okay. So you take after that. Tomorrow will continue next class. Okay. Fine. Thank you. Bye bye. Yeah.